Hello there, this is KLG Smartec. My name is Roman Ziad, and I'm a network solution expert at KLG Smartec. This is my face, this is my hand waving you. And today we're going to review, surprise, a network solution. This is going to be an AUTBUS implementation for EV charger park. So, without further ado, let me remove my face so that it doesn't mess up with other important content on the screen, and let's dive into our AUTBUS review. So, for those of you who are not familiar with AUTBUS, I encourage you to go on social media and onto our AUTBUS website, outbus.org, to get yourself familiar with AUTBUS and its technology. But for those of you who is not very familiar with the technology, we will briefly cover it right now. So, AUTBUS is the latest IEC standard for the field buses, along with other important players on the market like Ethernet IP, Profinet, Profibus, Modbus, and other. AUTBUS is the latest one. And on the next slide, let's see how exactly AUTBUS stands out. So AUTBUS is a multi-drop technology, and with this multi-drop technology we can support up to 254 multi-drop nodes like this, which is more than any other bus. To implement AUTBUS, we will require only a 2-wire twisted pair cable, and we can go up to 100 megabits per second of bandwidth and up to 500 meters of distance. AUTBUS is real-time deterministic bus by its nature, and it can be easily assembled into bus and redundant ring topology just out of the box without the need for any configuration. It also supports the multi-bus protocol tunneling. That means that we can tunnel existing protocols like Ethernet, like Modbus, like CAN bus through our AUTBUS. And what's important, to implement AUTBUS, we can use existing components on the market, which is SPE, single pair Ethernet components like cables and connectors. To clarify this, AUTBUS is not the same as single pair Ethernet, but the components are compatible. And with those benefits, what we can do with AUTBUS? Let's see one of the scenarios where AUTBUS shines the most. And this is a scenario of EV charging park implementation. So on the right, you can see the traditional implementation of a network for EV charging park. And this is by using an Ethernet switch in the center and the star topology, where we need to pull each individual cable to each individual end device, like EV charger or a camera or something other. While on the left, you can see the neat, beautiful solution that we can implement using AUTBUS. So what are the benefits? The benefit number one is obviously the redundant ring topology, because by using unmanaged switch, what you can do is only combine these devices into the star topology. While in this example on the left, you can see that no individual failure or no individual cable failure does not cause the entire network to fail. This is the advantage number one. The benefit number two is cable saving, because obviously on the diagram to the left, you can see that there is less cable. And we will use the less cable, the more nodes. We will save the more cable, the more nodes we will have on our network. And cable saving also means the cost saving. So this is advantage number two. And the advantage number three, of course, is the ease of expansion. In case we need to add an additional EV charging station here, we will need to pull another cable from this Ethernet switch to the destination. And in case we ran out of ports on our Ethernet switch, we will need another switch. While on the picture to the left, all we need to do is to expand the existing cable. And this is basically it. So, now that we have reviewed this solution, let's see the main components of this solution. And the main character is, of course, the AUTBUS coupler. Our latest model, we call it ABN300. And this device basically helps your other end devices without integrated AUTBUS interface to be connected to the AUTBUS network. Like EV charging stations normally have only Ethernet interface. And by using this AUTBUS coupler, we can connect EV chargers to our AUTBUS network. And another component of our solution is, of course, the cable. And for this solution, we will use this kind of cable. This is a 4-wire shielded cable called KLG cable. And we will use 2 of those wires for data transfer, while we will use another 2 of those wires for powering up our AUTBUS couplers. And this is what it's going to look like. So we will have normally what we have on our EV charging park is basically EV chargers, each every 2 or 3 meters. We'll have 1 or 2 cameras for video surveillance, and the internet uplink to manage all these devices. So here are the numbers. We will have 2 nodes on our network, 22 of course, 22 multi-drops on our network. We will have around 80-meter distance of our bus, and the bandwidth that we require is, based on our experience, is about 1.5 megabits per second per each EV charger, and around 10 megabits per second for the cameras and internet uplink. So the total bandwidth is somewhat around 50 megabits per second. And to emulate this on our test bench, we're going to use this kind of trick. We're going to emulate 20 of those EV chargers by using our Linux server connected via our Ethernet switch, and to emulate the camera, we'll use another computer. So now that we have seen all the details of that solution, let's go and see how it actually looks like. Join me on our next segment.